Hello class, today we're going to be covering z-scores. We're going to be looking at our notes, section 3.3, number 2. And let me go ahead and read that out to you as well. Use z-scores to compare the given values. Based on sample data, newborn males have weights with a mean of 3,196.7 grams and a standard deviation of 590.6 grams. Newborn females have weights with a mean of 3,101.4 grams and a standard deviation of 742.7 grams. Who has the weight that is more extreme relative to the group from which they came? A male who weighs 1,500 grams or a female who weighs 1,500 grams? We're going to use the formula to find out the z-score for the male first. Z equals x minus x bar all over s, which would be equal to x for the males is 1,500 minus x bar for the male would be 3,196.7 all over standard deviation for the males, which is 590.6. I ran out of room a little bit, so let's go ahead and write below this. And we find out that z is approximately negative 2.87. We will typically want to round to 2 decimal places on these. Now let's do the exact same thing for the z-score of the females. So z equals that exact same formula, x minus x bar all over s, which is equal to x for the females is still 1,500, minus x bar for the females is 3,101.4, all over s for the females, which would be the standard deviation for the females. That would be 742.7. Now again, plug this all in the calculator, and we can get ourselves a pretty close approximation of negative 2.16. And that was our female, by the way. Now, let's look at the next question. It wants to know, which has the weight that is more extreme? In other words, which has the weight whose absolute value is farthest away from 0? So let me go ahead and write that down for you. And looking at these values, we can see that the male has the more extreme weight. His z value is negative 2.87, which is further away from 0 than negative 2.16. If you have any questions about this video, please contact me through course messaging.